Hello, good evening.
Good evening.
Good evening.
Good evening. Ritika, you missed yesterday.
Yes, I had a lot of meetings yesterday and they were delayed. So,
So you work?
yes, I work.
Okay. Now, what do you work as?
I'm an interaction designer. It's sort of
Okay.
like UI UX.
Okay. Okay.
Yes.
So, till where did we study yesterday? Relational algebra. Yeah, I think we are supposed to start from the ER model. Okay. The screen is visible, right?
Yes.
Okay, we'll start with the entity relation model in database management system. Uh, it's basically a high level conceptual data model. We've already created diagrams as a recording for that. You can always watch that. But it is important. It will come in examination. They'll ask us to create the diagram and stuff. So we'll just talk about that right now. It allows you to describe the data involved in the real world enterprise in terms of entities and their relationship. It is widely used to create an initial design of a database and provides a set of useful concepts that make it convenient for a developer to move from a basic set of information to a detailed and precise description of information that can be easily implemented. It describes the data as a collection of entities, attributes, and relationships. So, this is your ER model, which is entity, attributes, and relationships. So you have entity, you have attribute, you have relationship. Entity has weak entity, strong entity. Attributes have key attribute, composite attribute, multi-valued, derived. Relation can be one to many, many to one, and many to many. This is your entity. So this is a student entity which is denoted by rectangle. If it's a strong entity, it's denoted by a normal rectangle. If it's a, oops, sorry. If it's a weak entity, it's denoted by double rectangle. Then these are your attributes like ID, name, address, and age. These are columns in your table. So suppose we design a school database. In this database, the student will be an entity with attributes like address, name, ID, age, etc. The address can be another entity with attributes like city, name, pin code, etc. And there'll be a relationship between them. So entity may be any object, class, person, or place. In the ER diagram, an entity can be represented as rectangles. Is there any disturbance in the sound? Because I'm not using a microphone.
It's not much. It's not significant.
Okay. So it's not disturbing, right?
No, I think it's okay.
Okay. Fine. Consider an organization as an example manager, product, employee department can be taken as an entity. Entity set or type, a collection of similar kind of entities is called an entity set or an entity type. A collection of all the students entity form an entity set student. An entity identifier is an attribute or set of attributes which attain unique value for every distinct entity in a set, and it's called key attribute. And its values can be used to identify each entity uniquely in a given set. Weak entity, an entity depends on another entity called a weak entity. The weak entity does not contain any key attribute on its own. The weak entity is represented by double rectangle. Let me put a microphone. I think there will be disturbance. Just 1 second. Actually, I'm in a hotel in Mumbai, so the things are not in my control here.
Are you saying something? I think you're on mute.
Okay, am I audible?
Yes, yes.
I think when I put the microphone, my audio went off. External microphone button. Okay. So I was talking about the weak and strong entity. In this example, loan is a strong entity. It has its key attribute on its own, and installment is a weak entity. It doesn't have its key attribute on its own. This is dependent on the loan entity. That's why this is weak and this is strong. This is denoted by a rectangle. This is denoted by double rectangle. Strong entity set which contains at least one key attribute. For example, is in this is loan entity which contains a key attribute. Attribute is used to describe the property of an entity. Eclipse is used to represent an attribute. So these are your attributes. Types of attributes: you have a simple attribute, an attribute that cannot be further divided into small parts, which is atomic. These are simple attributes, for example, first name, middle name, and last name. Composite attribute, an attribute that can be divided into many other attributes. For example, name. Name can be divided into first name, middle name, and last name, so that's a composite attribute. Single valued, an entity attribute having a single value. For example, age of a student will always contain a single value. That's why it's a single valued attribute. Multi-valued, containing multiple values. For example, one student can have more than one phone number. It is represented by double oval. Then you have derived attribute, which means you can derive someone's age if I give you the date of birth, and those attributes are called derived attributes. Then you talk about the relationship with ER diagram. In this diagram, there are two entities, teacher and student, and the relationship between them is teacher teaches student. So when you're drawing the ER diagram, and when you're supposed to show the relationship between two entities, you will use this diamond shape, and you will put the relationship inside of that. Now, the different types of relationships: one to one, one when only one instance of an entity associated with the relationship, then that's your one to one. For example, a female can marry to one male, and a male can marry to one female. So that's married to is a relationship. Female and male is are two different entities, and it's one to one relationship. So one female can have multiple husbands, and similarly, sorry, one female can have one husband, and one husband can have one wife. So that's you're seeing a one-to-one relationship. One-to-many relationship, when only one instance of an entity on the left and more than one instance of entity on the right associates with the relationship, that's one-to-many. For example, a scientist can have multiple inventions, but an invention can only have one scientist. Then you have many to one. Notice these numbers. This is a denotion when you're writing the relationships. Uh, one to one is denoted by one is to one to many by one is to n, many to one is m is to one. So many to one means when more than one instance of entity on the left and only one instance of entity on the right associates with a relationship, that's many to one. For example, a student can enroll only for one course, but a course can have multiple students. Many to many is denoted by m is to n, where more than one instance of an entity on the left and more than one instance of an entity on the right associates with the relationship. For example, uh, employee can be assigned multiple projects, and one projects can have multiple employee assigned to them. That's your relationship with the ER diagram. Now I talk about the cardinality of a relationship. Cardinality means number of instances of an entity associated with another entity participating in a relationship. Based on the cardinality, binary relationship can be further classified into following relationship categories: one to many, many to one, and many to many, which you already discussed. Degree of relationship set is the number of participating entry sets. The relationship between two entities is called a binary relationship. A relationship among three entities called a ternary relationship. Similarly, a relationship between n entities is called n-ary relationship. Recursive relationship, a relationship in which both the participating entry sets are the same entity set. However, the role of the entity set in each participation is different. Participation constraints specify whether the existence of an entity depends on being related to another entity, while relationship types of participation constraints are total. When all the entities from an entity set participate in relationship set, it is termed as total participation. The participation of an entity set course in the relationship set taught by can be said to be total because every course must be taught by the faculty. Partial participation, when it is not necessary that all the entities from an entity set to participate in relationship set, it is termed as partial participation. So just like to make these things bold. So cardinality means number of instances of an entity associated with another entity. Degree of relationship is the number of participating entity sets. Recursive relationship, where both the participating entity sets are the same entity sets, which means, for example, one entity is related to the same, related to itself. That's recursive. Specify whether the existence of entity depends on its being related to another. So it checks whether existing existence of an entity depends on its being related to another. On being related to another entity. A total when all entities from an entity set participate in a relationship set. when it is not necessary for all entities from an entity set to participate in relationship. Okay, we'll look closely on the ER diagrams. The logical structure of a database is modeled using ER diagram, which is entity relation model, uh, and is graphically represented with the help of an ER diagram. There are three main objects here. You have an entity set, which is denoted by a rectangle, which is this. You have attributes, which is denoted by the shape ellipse, and then you have relationship sets, which are denoted by diamond shape, which is this. Okay, strong entity, single border for the rectangle. Weak entity, double border for the rectangle. You have attribute. Uh, there will be multiple attributes in an entity, and the one which is the key attribute will be you have to underline the key attribute there. Derived attribute means, like, for example, age is derived from the date of birth. So when one attribute is derived from another, it is denoted by this dotted eclipse shape. Relationship is denoted by this. Identifying relationship is double border. 1 second. So, May, what is identifying relationship? Do you know?
It's between a strong entity and a weak entity. The
Okay.
weak entity doesn't have an ID, so the strong entity is used to identify it.
Okay. So when we are creating, like, for example, these two rectangles, strong and weak, then
Yeah,
when we put this sign, we will use this sign.
yeah,
Okay. Then you have composite attributes. An attribute which can be further divided into multiple attributes. That's your composite. Multi-valued attribute means that it can have multiple values. For example, a student can have multiple phone numbers. When you have total participation, you will denote it by a double line here between the relationship. And we studied about the total participation, that when all the entities from an entity set participate in the relationship. For example, uh, the participation of entity set course in relationship set taught by can be said to be total, because every course must be taught by the facility. So that's total participation. Partial participation is denoted by um, single line over here. So this is partial participation of E2 in the relationship. Here, E2 is totally participating in the relationship. So these are the symbols you'll use to draw them. This is an example of a college database based on what we've studied. Let's say it looks a little overwhelming, but let's break it into parts. So we'll start from here. So we have a student entity. We know that we use rectangle to draw this. Then you have three different attributes, which means in the student table, we'll have three different columns: roll number, name, and address. As we discussed, when you have a key attribute, like a primary key, you'll underline that. Then we have another entity called course, which has course ID, course name, and duration as attributes. Now, these two entities have a relation, and we know that when we want to denote a relation, we use the rhombus or the diamond sign. So, what is the relation between them? It's ops. Okay, so a student opts a course. Now, what type of this relationship is? That is denoted by one to many or many to one. So in this case, because you have n here, which means many, and over here is one. So one to many. So a course can have multiple students, but a student can only enroll in one course. That's why you have one over here on the right. There is a double line here, which means total participation by student into this relationship. So all students will have a course, well, at least one course. That's the meaning of that, right? All total participation means all students will have at least one course, right, Sumaya?
yes,
Okay. All right. Then again, we have two more. or let's talk about this one first. So we have a entity called guardian, but because it has double borders, it is a weak entity, which means it is dependent on another entity. And what is dependent on is dependent on the student. And what's the relationship? Relationship is assisted by. And as we discussed earlier, that in case if you have a relation between a strong entity, which is student, and a weak entity, guardian, then you're going to use a rhombus, which is a diamond sign with double borders. And that's what we're doing over here. Now, what is the type of relationship? It's um, one to many, which means one student can have sorry, uh, yeah, one student can have. So, Maya, why is n here? One student will have multiple guardian.
Yes, looks like that.
Okay. Okay, we'll go by whatever is denoted here. So I'm assuming mother and father. That's why it's multiple, or maybe somebody is relative. But one guardian will always be to one student only. So that's many to one. Okay. Then it has these attributes: name, address, and relationship. And then we have another entity called department, where the relationship between student and department is enrolled, and that's one to many, and this is total participation, which is a student uh, can have will always be having department. Okay, so yeah, so that's how all these guys are there. It's just a similar way of relationship between them. You can change it multiple times and kind of draw this graph depending on the question you get in the examination. Okay, conversion of ER diagram into relational database. We did this on another recording. You can watch that later. File organization in Dbms. When the size of the database is large, databases are required to be stored in secondary memory of the computer, such as hard disk. File organization is a way the files are arranged on the disk, and access method is how the data can be retrieved based on the file organization. Database design involves the process of logical design with the help of ER diagram, normalization, etc., followed by the physical design. The key issues with the physical database design are: the purpose of physical database design is to translate the logical description of the data into technical specifications for storing and retrieving data for the DBMS. The goal is to create a design for storing data that will provide adequate performance and ensure database integrity, security, and recoverability. Basic inputs required for physical database design are normalized relations, attribute definitions, data usage, entered, retrieved, deleted, updated, requirements for security, backup, recovery, retention, integrity, DBMS characteristics, performance criteria such as response time, requirement with respect to volume estimates. We talk about physical records. Physical records are a group of fields stored in adjacent memory locations and received together as a unit. These are stored in secondary storage devices. The issues relating to design a physical database file. Is it repetition? No, no. Okay. Physical file is a file stored on the disk. Main issues relating to physical files are constructs to link to pieces of data, sequential storage, pointers, file organization, how the files are arranged on the disk, access method, how the data can be retrieved based on the file organization, database storage on hard disk or SSD. The database are stored persistently on hard disk or SSD if they are very large. Primary storage is very expensive, or they need to be stored using non-volatile storage. Each hard drive is usually composed of a set of disk platters. The entire disk can contain a large amount of data, which is organized into smaller packages called blocks. A block is the smallest unit of data transfer between the hard disk and the processor of the computer, having the fixed assigned address. A solid state disk, which is SSD, are made up by using flash memories. These SSD devices also provide similar block oriented access to the data. However, since they do not have physically moving component, they provide lower latency and lower access time than that of the disks. So data can be stored on hard drive or SSD. It is stored in form of blocks, which is like a single unit of the data transfer between hard disk and the processor. Um, SSDs provide low latency and lower access time than that of the disks. There are two basic ways of storing a record on the disk. Fixed length records, all the attributes are assigned equal space in the terms of bytes. Variable length record, each record of a table may be of different length. Some attributes may be null. File organization is used to organize the content of a file on a storage device. Main objective of the file organization are records can be selected with ease, and CRUD should be easy, avoid duplication of the record in the result, and efficient storage of records. Using the primary key, we can access the records. The type and frequency of the access can be determined by the type of file organization which was used for a given set of records. Some of these file organization types are sequential, indexed, heap, hashed. Types of file organization, we'll start with the first one, which is sequential. In this method, the files are stored in a sequence or consecutively by primary key fields. The kind of file organization works well with the tasks in which nearly every record of the file is required to access, such as payroll system. It is fast and efficient when dealing with large volumes of the data that needs to be processed. Batch system, periodically, batch system. Operation on sequential file organization, file creation. It will be efficient if the transaction records are ordered by the key record location as it follows the sequential approach. It is inefficient. On, on an average, half of the records in the file must be processed to locate the record. So this is the structure of the sequential file. You have key field. That's the beginning of the file. That's the end of the file. You have record 1, 2. So it's everything in sequential order. So key takeaways from this is that in this method, files are stored in a sequence or consecutively by primary key in the primary key order. Works well where nearly every record is required to be accessed. Dealing with large volume of data. Okay, let's move on. Next one is the sequential file organization. So operations on sequential file organization, it will require you to browse through all the records to check if such records already exist or not. Thus, entire file must be read and written. Efficiency improves if the group of records are created together. This operation could be combined with a deletion modification to achieve greater efficiency. Record deletion, entire file must be read and must be read and written. Efficiency improves with greater number of deletions. This operation could be combined with addition and modification transactions to achieve greater efficiency. Then you have record modification, very efficient if the number of records to modify is higher and records in the transaction file are ordered by record key. Update, insertion, deletion of the record in a sequential file require new file creation. Can we reduce the creation of this new file? Yes, it can be done easily if the original sequential file is created with holes, which are empty records space as shown in the figure. So this is a structure of the sequential file with empty space for record insertions. As we already know that the data is created in form of blocks in the memory, and this is block 1 where you have records, record 1 2 3. Then you have, so it's basically you have record 4 5th and 6 are, so it's kind of in different blocks in the sequential file. Okay, then you have index file organization. It organizes the file with like a large dictionary. Records are stored in order of the key, but an index is kept, which also permits a type of direct access. The records are stored sequentially by primary key values, and there's an index built over the primary key field. To locate a record in a sequential file which is not indexed sequentially, on average, you may read about half the number of records. Therefore, retrieval of a specific record in a sequential file is inefficient, especially if the file has a very large number of disk storage blocks. The use of index in sequential file improves the query response time by adding an index which is defined as set of index value address pair. An index is a mechanism for faster search as the size of the index is much smaller than the original file. Okay, I'm not spending too much time on topics which I feel that it's not that important, not been asked in the paper or even assignment. So I'm just reading that and moving on because we have a lot to cover. Types of file organization: hashed file organization. Hashing is most common form of purely random access to a file or database. It is used as an optimization technique to access columns that do not have index. Just 1 second. Hold on. Colo? नीचे नीचे रखो रेड पेंट नहीं आप आप देखना है खोल के देखिए बंद कर दो Okay. Hashing involves the use of hash functions. Input to a hash function is the value of the attribute or set of attributes of a record that are used for file organization, and the output is the block address or page address where the record can be found. Insertion or search on a hash key is fast, but range search is slow as it suffers from the disk space overhead. Okay, this is important. Database indexes, use of an index in relational database management system. Indexing is used to optimize the performance of a database by minimizing the number of disk access required when a query is processed. So in the previous slide, we learned about that um, storing index will definitely consume less memory compared to the entire record. So indexing is used as an efficient way of accessing the database. Example, a book has a table of content and it's easy to find it. So if you're reading a book and if you're looking for a particular topic, of course, you're not going to go and search the entire, you'll turn all the pages. You'll go directly look at the table of content and see where that topic is and just go to that page number and just find that. So that is why indexing is similar to that, and that's how indexing is pretty useful. So in the structure of the index, you have a search key, and then you have the data reference. This is reference to where the data is located. So once you know the index, you can directly go to that particular data and find it. The index is a type of data structure. It is used to locate and access data in a database quickly. Indexes can be created in some database columns. The first column of the database is a search key that contains the copy of the primary key or candidate key of the table. The values of the primary key are stored in sorted order so that the corresponding data can be accessed easily. The second column of the database is a data reference. It contains a set of pointers holding the address of the disk block where the value of the particular key can be found. So we learned that data is stored in form of blocks. Um, in this structure, the first one is your search key. This search key can contain either the primary key of that particular tuple. It can contain a candidate key also. Uh, Basically, a unique key through which you can identify that record. Then in that next one, you have data reference. This is basically the address pointer to where that record is, where that block is, basically where it contains data. So let's kind of highlight some of the important points here. So what's is used for is used to optimize the performance by minimizing number of disks access required when the query is processed. The index is a type of data structure used to locate and access database quickly. Can be created using some database columns. First column first column is the search key that contains the copy of the primary key. Values of the primary key are stored in sorted order so that they can be accessed easily. Second column is the data reference. It contains a set of pointers holding the address of the disk block. Cool. I think this is very easy to understand. So now we talk about the indexing methods. Indexing methods, you have ordered indices, primary index, clustering index, secondary index, dense and sparse index. So we talked about indexing, which is basically used to optimize the performance by minimizing the number of disk access. You have search key, data reference, all of that. So we spoke about the indexing, how the indexing works, how it makes it easy for us to access the data quickly. Now we talk about the methods of indexing, and these are the methods basically. So we start with the primary index. So types of indexes. First is primary index. So here in the primary indexing, the index is created on the basis of primary key of the table. We store the first primary index of the block and the block pointer address pointing to that block. We already spoke about it in the indexing. This is how it works. You have the primary index value. So this is your actual table. This is in all the records. It kind of grouped it in a block. So remember we spoke about like data is put in blocks. So these are different blocks basically. So a block of 4 records each. These are your primary keys. Let's say enrollment number is your primary key. So this is your indexing. This is your index, how you have book in which you have different pages. So think about like that. So this is a page which contains a lot of content. You have a page number. So think of that as a block number. So in your book, you will have the page number. So page number is this, and something unique to identify is this. Okay. So these primary keys are unique to each record and contains one-to-one relationship between the records. As primary keys are stored in sorted order, the performance of the search operation is quite efficient. The primary index can be classified into two types: dense index and sparse index. So we saw the diagram that there are different methods in indexing. One is primary index, and this primary index has two methods. One is dense and second is sparse. Okay. So dense and sparse, and here you can see that your primary index, you have these pointers, block pointers, this address containing address of this particular block. This is containing address of this block. And usually not all the keys are put there, only the first one. So say from this block, it's only put the 348 ending with 348. It didn't put anything else because we know that from 48 to 52 it will all be available here. Similarly, here we put the first one, we don't put all of them. So once we reach here, we know that we'll be able to get anything, all the data from here. Okay, so the dense index contains an index record for every search key value. It makes searching faster. In this, the number of records in the index table is the same as the number of records in the main table. So unlike this, where you had like one primary key for like 4 records, here it's like one-to-one mapping. So one primary key will be matching to the one record. So that's why it's dense. It needs more space, of course, to store index record itself, because the number of record equals the number of the primary key. Uh, Basically, this setup here. Oops. The index records have the search key and the pointer to the actual record on the disk. Now I talk about the sparse index. In the data file, index record appears only for a few items. So here, the mapping is not done for every one of them, but only few of them. So you can see that it skipped the USA. It doesn't have any index here. Skipped it. Unlike dense index, where each item points to a data record in the main table, in sparse index, each item points to a block in a gap. So, which is what we saw here, pointing to that block. Let me fix one of the things. Not spare, but sparse. Okay, now we talk about clustering index. In clustering indexing, two or more columns are grouped together to uniquely identify the records. A clustered index can be defined as an ordered data file. Sometimes the index is created on a non-primary key columns which may not be unique for each record. In this case, to identify the record faster, we'll group two or more columns to get the unique value and create index out of them. It's called clustering index. So this is talking about that it can group two or more columns together, two or more attributes together to form your key here. These groups are called clusters. The record which will have similar characteristics are grouped and indexes are created for these groups. Now we talk about secondary index. So we spoke about primary, now secondary. So in secondary indexing, to reduce the size of the mapping, another level of indexing is introduced. In this method, a huge range of columns is selected initially so that the mapping of the first level becomes small. Then each range is further divided into smaller ranges In the first level, um, large range of numbers is selected. Then mapping of the first level is stored in the primary memory so that the address is fetched faster. So from here, a large number of indexes are selected. Then they are further narrowed down to a small number of index. Second level, the mapping of the second level and the actual data is stored in the secondary memory. So large number of IDs are selected. They are put here in this index. Then again, out of this, we derive less number of index. So this is pointing to this, and this is pointing to this. So this is secondary index. Now there's a question that if two indexes were created in a database, one on the primary key and the other on the secondary key, which of these two indexes will be of more advantage? Now the answer is a primary index is an index on a set of fields that includes unique primary key and is guaranteed not to contain duplicates. In contrast, a secondary index is an index that is not primary key and may have duplicates. Searching data using primary index is efficient because it stores the data in sorted order. Primary index requires the rows in data blocks to be ordered on an index key, while secondary index does not have the impact on how the rows are actually organized. So in the primary indexing, everything is in order, but in secondary, it doesn't matter if they are in order or not. Moreover, there's only one primary index where there can be multiple secondary index. Q&A. A file contains 40,000 student records of 200 bytes each, having 1 KB as the size of the block. What would be the size of primary index? If the size of the primary key is 4 byte and the block address is 8 byte, what would be the average number of block accesses to access the record using the index? And this is from the textbook. Number of accesses without using the primary index. Number of records in the file is 40,000. Block size is 1024. Record size is 200 bytes. Number of records per block is 5 because you divide the block size by how many the size of the each record. So you get 5 records per blocks. So I showed you in the diagram, like for example, these not this one. Yeah, for example, this one. So each one of them. This is a block. How many records will it have? So that's a calculation there. So 5 records per block. Number of disk blocks acquired by the file. So the whole file. So we spoke about like how many records per block, and now we talk about how many total blocks in the disk. So that's calculated by number of records, like total number of records, divided by records per block. So total number is this, and per block is this. So that's why there will be total number of disk block will be 8,000, and each block will have 5 records, and total number of records is 40,000. So now the file is in the order of primary index, so binary search can be employed to access the file as 2 to the power 13 equals this. Thus, about 13 block accesses would be required to locate the block containing the desired order record. So this is asking that what would be the size of the primary index if the size of the primary index is 4 byte and the block address is 8 byte. So here it's calculating that information. Number of accesses with primary index, size of an index entry is 4. I don't think this will be asked. I'm not going to go too much into it. Okay. Which of the following indexes are dense index? Give reasons. So is primary index a dense index? No, it is sparse as 1 entry per block of the data. Clustering index is dense because 1 index entry for each attribute value. Sparse if multi-level index is used. Then it's asking, is secondary index on alternative key dense index? Yes, it is dense as 1 index entry for each attribute value. Then secondary index on a non-key attribute with a unique attribute value, is that dense? Yes, it is dense as 1 index entry for each unique attribute. So we studied that there are two types of indices, sparse and dense. Sparse, uh, sorry, a dense is where each index will map to each record, and sparse is where each index will map to a block of record, and one block can have multiple records. Now, implementing index using tree structure, binary search tree, BST, as indexes. A binary search tree is rooted binary tree data structure with key of each internal node being greater than all keys in respective nodes left subtree, less than one in the right subtree. A node on the BST stores key value address pair. A binary search tree as a data structure is suitable for indexes if complete indexes containing in the primary memory. However, if the indexes are quite large in the nature and require a combination of primary and secondary storage, then you can use B tree data to structure uh, to implement the indexes. So, so when you're creating the binary tree, basically it's saying that the left side, uh, each internal node should be greater than all the keys, and less than one in the right subtree. B tree is a self-balancing search tree and used to reduce the number of disk accesses. Since the height of the B tree is low, so total disk accesses for most of the operations are reduced significantly compared to the balanced binary search trees. Multi-key file organization. Multi-file organization allows access of records on more than one key field. Two of the most commonest techniques are multi-list file organization, which maintains an index of each secondary key. The index of secondary key contains, instead of a list of primary keys related to a secondary key, only one primary key value related to the secondary key. That record will be linked to other records containing the same secondary key in the data file. The multi-list organization enhances the query answering capability of databases on multi-key values. The number of records in an index entry determines the length of index on a specific attribute value. This enhances the performance of searching when more than one search terms are used, as you can select smaller list, and then apply second search term on it. Inverted file organization. An inverted index is an index data structure storing mapping from content, such as words of number, to its location in the document or a set of documents. This file organization is somewhat similar to the multi-list file organization, with the key difference that in multi-list file organization, index points to a list, whereas in inverted file organization, the index itself contains a list. Okay, I think we'll stop here. We'll just do a bit of recap of the database file organization. I'll just highlight this. We're not going to do the boring topics next week. So boring, this file organization thing. Okay, advantages of database management system. So a database management system creates and manages database. With the help of Dbms, programmers can easily retrieve, create, update, and manage data. There are various functions performed by Dbms which gives an upper hand over the traditional file system, and users can also create personalized database as per requirement. So first advantage is ease of access. In the file system, different files are created for each user which they can access. In Dbms, uh, it removes redundancy by granting access to users and deciding which and how many parts of the data is accessible to them from the database. Storage and management of data. Unlike file system, data can be directly stored in form of objects, making it easy to query. Avoiding duplicates and redundancy. In file system, the storage of the data may happen multiple times. In DBMS, data normalization is used to avoid duplicate data. Concurrent data accessing, users can access data simultaneously through different applications. Database integrity, which says that data should be accurate and consistent. This is implemented by enforcing the checks on constraint. Data of the database is not allowed to violate these constraints rules. For example, a constraint on age of an employee can be between 18 to 70 years only. While entering or modifying the data of the age on the employee, the DBMS should enforce this constraint. So just to recap, ease of accessing in file system, different files are created for each user, but in DBMS, it decides which user will be given how many parts of the data access. So it removes the redundancy by granting the access to users. Then we have storage and management of the data. So in the file system, data can be stored in form of objects. Unlike file system, data can be stored in form of objects. So if the data is in object form, then it's easy to query. Avoiding duplicate and redundancy. So in file system, there could be multiple files in a folder with the same name. So there's duplication, but in the DBMS, it uses normalization, which is dividing the a single table into multiple tables, multiple relations, to avoid duplication of data. Then you have concurrent data accessing, which means that multiple users can access the data simultaneously. You have database integrity, which means data should be consistent and accurate, and it is enforced by uh, using constraints. Types of DBMS architecture, you have physical and then you have logical. Logical defines the data organization and access at different logical levels. There is three-level architecture of DBMS. Then you have physical architecture, which defines various components like DML precompiler, DDL compiler, file manager, database manager, query processor, administrator, file indices, data dictionary. Now we talk about the logical architecture, which contains the three-level hierarchy. You have an external view, you have a logical, conceptual or logical view, and then you have internal or physical view. Sorry, physical level. Um, the three-level database architecture was designed by ANSI to for data abstraction for different types of users. Physical internal level, conceptual logical level, external or view level. Physical and internal level, this is the lowest level of the three-level architecture. Uh, it basically decides how the data is going to be stored. And in the lowest level, the data is stored in external hard drives in form of bits. And a little higher level, it can be said that the data is stored in files and folders. The physical level also discusses the compression and encryption techniques. Then you have the conceptual level or logical level. This is the second level basically, and second level after the physical level. And this doesn't care how the data is stored. It is more concerned with the structure of the data, the relationship, and the constraints on the database. Describes how database appears to the users conceptually and relationship between various data tables. It does not care how the database is stored. External or view level, this is what the users will see, and this will decide what each user will see because we don't want to show everything to the user. This is the highest level in the three-level architecture and closest to the user. It only shows relevant database content to the user in form of views and hides the rest of the data. So different users can database see the database as different view as per the individual requirements. Okay, before we jump on that, we'll take 2 minutes. We'll pause for 2 minutes. There's prayer going on. Oh, Kritika, can you read this?
Yes. Data independence and its relation with three-level DBMS architecture, mapping between different levels. Data independence means data independent. Should I speak louder?
No, no, you're fine.
Okay. Data independence means a change of data at one level should not affect another level. So we should be able to modify the schema at one level of the database system without altering the schema at the next higher level. The three-level architecture defines a single database system across all the three levels. Therefore, different levels must map with each other. This mapping leads to the concept of data independence. There are two types of data independence: physical data independence, which is defined as the capacity to change the internal schema without having to change the conceptual schema. If we do any changes in the storage size of the database system server, then the conceptual structure of the database will not be affected. It is used to separate conceptual levels from the internal levels. Physical data independence occurs at the logical interface level. Logical data independence. It refers to the characteristic of being able to change the conceptual schema without having to change the external schema. Logical data independence is used to separate the external level from the conceptual view. If we do any changes in the conceptual view of the data, then the user view of the data would not be affected. Logical data independence occurs at the user interface level.
Okay, so just a recap of this. So basically, all it's saying is that data independence means a change of the data at one level should not affect another level in the three-level hierarchy, three-level architecture. And there are different types of data independence. You have physical data independence, you have logical data independence. There are two basically types of them. And the first one basically separates the physical with the conceptual, and the second one separates the conceptual with the user level. This is saying that if you make any change to the storage size, etc., it should not impact the conceptual level. And this is saying that if you make a change in the schema at the conceptual level, then it should not affect the user level. This happens at the um, conceptual or logical level, and this happens at the user level.
Okay, go on.
Physical DBMS architecture. The physical architecture defines the software components used to process and enter data and how these software components are related and interconnected. There are a number of key functions which are similar to most database management systems. The components that normally execute these functions are shown in the figure.
Okay.
DML precompiler. Every DBMS consists of a data manipulation language (DML), which is used for data insertion, modification, data access, etc. The purpose of DML precompiler is to translate the DML commands, which are written as a part of the application programs, into related procedure calls so that they can be executed to perform the desired operation. In addition, this component of the DBMS also coordinates the translation of queries, which are input to the query processor component. DDL compiler. It is used to compile a DDL statement into related tables, which include metadata, constraints, access rights, etc. The metadata tables are stored in the data dictionary or system catalog. This metadata is used for providing information about the tables to other components of DBMS, protecting data, and enforcing data integrity.
So DML pre-compiler translates the DML commands uh, so that they can be executed to perform the desired operation. DDL compiler used to compile the DDL statement into related tables.
File Manager. All the tables and metadata of the database are physically stored as files under the control of file subsystem of the operating system. The file subsystem of the operating system has generic features, which may not be sufficient for a DBMS file. The file manager component of the DBMS keeps track of all the data files, their index files, and all other related information files of a database system. Database manager. The role of database manager is to accept the requests of data access or data manipulation by the user queries and application programs and performs the relevant action on the data taking the help of data dictionary and file manager. Database manager protects the data from unauthorized access and manipulation. It also enforces integrity constraints.
Okay, so file manager keeps track of all the data files, their index files, and other related information files. Database manager accepts the request of the data access by user queries and performs relevant actions. It also protects the data from unauthorized access and manipulation and enforces integrity constraints. So, Maya, did you find any other exam papers besides one single one that you've shared
No,
for
the
each
others
subject?
are of the old syllabus.
Oh, okay. Yeah, of course, it'll only have one paper, right,
Yeah.
in one semester, right?
A major components of database manager. Authorization control is used to verify the credentials of a user to ascertain if he or she is an authorized person to access or modify the data. Command processor converts the DDL, DML, or other programming language commands to executable sequence of code. Integrity checker checks if the data is being inserted in a database or is being modified, follows all the specified constraints on the database. Query optimizer tries to optimize the processing time of different queries. Transaction manager is one of the important components which checks
Components.
is one of the important components which checks if the user has a right to perform a transaction. Scheduler component manages the consistency of data while concurrent transactions are being processed by a database. Recovery manager is responsible for recovery of a database system to a consistent state in case of a failure. Buffer manager optimizes the process of transfer of data between main memory and the disk where database is stored. The buffer manager is also termed as the cache manager.
Okay. Uh, Kritika, where have you taken your education from? Which college?
Delhi University, Indraprasth College for Women.
Okay, so you were in Delhi.
Yes, for college.
Okay. Okay. And Sumaya, what about you?
I did my BSc from IGNOU.
Sorry,
I graduated from IGNOU itself.
IGNOU itself. Wow.
Yeah.
And your schooling, like your inter, SSC, HSC.
I was actually homeschooled, and I did the examination externally from NIOS.
Wow. So how did you work on your pronunciation? Like, if you did you like speak to those teachers? Did they train you? If you did you homeschooling, how did you learn the pronunciation, English language?
Just by speaking, we speak at home.
Okay. Cool. Sounds good.
Where did
Right.
you study?
I have studied from CBSE board from Sunbeam School, and I've done my graduation from Mumbai University.
Oh, okay.
Yeah, but I'm lucky to have the teachers who were speaking good English, and that's why my pronunciation is like that.
Mm-hmm. Yes.
Okay, go on.
Query processor,
Hmm?
physical DBMS architecture software components.
Hmm.
Query processor. Every DBMS consists of a query language, which enables database creation, data manipulation, data retrieval, and data control operations. In general, this query language processes consist of two basic components. The first one passes the query language into the native database language, and the second optimizes the query and prepares the code for a query execution. The parser checks the syntax of the query, converts the query into a sequence of tasks, and sends these tasks to the query optimizer. The query optimizer is responsible for generating a set of alternative query evaluation plans. Database administrator. The role of a database administrator (DBA) is to monitor control the database creation at different levels of a three-level architecture and mapping between the levels, modification, access, query response time, security, recovery in case of failure, etc. Data files, indices, and data dictionary. Data files. The data is stored in the data files. The data files can be standard files or encrypted files. These files in general are not accessible directly to any system user. Indices are stored in the index files. Indices provide fast access to data items.
We just spoke about the indexing,
Hmm.
right? Which were storing them just like a index of a book.
Right. Data dictionary or directory. It is designed to store metadata, which is data about data, in a database system. A good data dictionary allows efficient data access as it can provide a roadmap to guide users to access information within a large database. A database system required that the data should be structured in such a manner that it allows easier data access and manipulation operations. These structures are termed as database models.
Let me fix this. There's some issue here.
Yes.
Requires, not required. Present tense. Just a
These
moment.
structures.
Okay, go on.
A conceptual model, user entities, their attributes and relationships among entities. A hierarchical model uses data hierarchy. Record-based logical models. Object-based models uses objects as key data representation components. Semi-structured model uses user-defined tags. Database backend. Most of the database systems are deployed in a multi-user environment, either as centralized or distributed system. A database server, which is at the backend, manages and controls the physical data. It also provides integrity, security, and access control to multiple clients' requests. Need of utilities in commercial database system. Utilities are special purpose software which are provided to support additional features in support of a DBMS. Two such utilities are for backup or restore, to protect data against any failure, and load unload to load data from one hardware or software.
Okay.
Difference between network and hierarchical models. A network model stores of basic entities as data records, and points are used to represent the relationship between them. A hierarchical model uses almost similar model to represent data of entities, but the relationship between them is implemented as a hierarchy. Relational database, RDBMS. Um, RDBMS is based on the relational model introduced by EF Cod, example SQL, MS, MySQL Server, IBM
MS SQL
MS, okay, MS SQL Server, IBM DB2, Oracle, MySQL, and Microsoft Access are RDBMS.
Hello? We lose that? She's there. Okay, I'll go on by the time she's back. RDBMS database uses tables to store data. Each table is called a relation, which is a collection of related data entries containing rows and columns. Uh, each table represents some real world object, such as person, place, or event about which information is collected. So when they ask about RDBMS, we explain that it's based on the relational model. We just derive this word from here, relational model. We give basic information like it was introduced by EF Cod. Examples of these like SQL, MS SQL Server, Oracle, MySQL, etc. And then we explain what is included in this RDBMS. Like it has tables, it has relations, attributes, all of those things. So um, each table is a relation, which is a collection of related data entries containing rows and columns. Each table represents some real-world objects such as person, place, events about which the information is collected. What's the difference between relational database management system and object-oriented database management system? Relation database management system is based on tables in tabular form, object-oriented based on objects, and relational DBMS handles simple data. OODBMS handles large and complex data. Uh, in the relational database management system, an entity refers to a collection of similar items having same definition. Here, a class refers to a group of objects having common relationship, behavior, and properties. RDBMS handles only data. OODBMS handles both data and the functions operating on that data. Uh, RDBMS use objective is to keep the data independent from the application program. OODBMS is used to implement data encapsulation. So keep the data independent from the application program to keep the data encapsulation, implement encapsulation. Okay. Here a primary key identifies the object in a table uniquely. Your object ID represents a object uniquely in the group of objects.
Kritika is back. Can you add her?
Kritika?
You
Oh,
need to
I have
add
to
her in
add
the
a.
broadcast.
Okay.
Thank you.
Okay.
Uh,
Kritika, the place I am at, I get to
mhm.
hear all possible sounds. I get to hear a goat screaming. I get to hear, मुर्गा सुबह अजान देता है. लेकिन हमारा मुर्गा ना 10-11 बजे को सो के उठता है सबके साथ. 5 बजे नहीं उठता वो.
That's what are you doing in Mumbai? Are you there for
Uh,
work?
yeah, for some work. So I'm staying in a hotel with my sister and mom, and yeah, the place we are at is a very busy place. It's like in the middle of the. It's near VT in Mumbai. Have
Okay.
you heard of Muhammad Ali Road?
No, I haven't. No.
Okay, okay. So yeah, a lot of good eating joints. So every day it takes all. It kind of wastes my half an hour just to decide what to eat because there's so many options. So I'm
Uh,
kind of enjoying Mumbai's food.
that's a good use of time. That's not
Yeah,
a waste of
really.
time. You get good food. What more do you want?
Yes, yes, really good food. I ordered a
Mm,
table because I was sitting on bed for quite some time and my back was paining, so I ordered a table today. So
okay.
yeah,
I mean, I really appreciate that you conduct these sessions, like despite everything despite your work and travel and everything.
yeah. I mean, I think it's a good way of studying because then you can share knowledge. Like for example, when me and Somaya discuss things, sometimes she is able to share things that I
Mm,
didn't know about. And when you discuss topics, this kind of gets into your head.
yes.
The
Yes.
course is so big, it's so huge, and I cannot tell you. I mean, I can't sit. I mean, at least with work and everything, I can't sit for continuously for 3-4 hours and study. So, one way of doing these sessions for about 1 hour, that 1 hour is like a complete focus. You can't move
Mm,
during that period of time. So it's very productive.
yes. I think Sumaya helped me also a lot.
Yeah.
Like even after the first semester,
Hmm.
I actually did not do well in the C and Python subject last semester,
Hmm.
and then I panicked a lot, and then I talked to Sumaya, and she was like, "We can apply for evaluation and everything," and
Yeah,
then I got like a lot better marks.
that's good.
So
That's good.
um, yeah, and she also helped me with like a lot of the videos and all of that. I think the normalization one was so good. I watched the entire playlist, and
Yeah.
now I only use those examples. I don't use the book examples. Um,
Excellent. Excellent.
so yes.
That's like a 8 marks question, I think. Something like that. So 4 to 8 marks of question. Definitely, it'll definitely come. I'm pretty sure. That and then the ER diagram, all of those things. Next week, we're going to be mainly focusing on the questions that are important, and we're not going to be discussing anything that's not important. We'll make sure first we'll revise that. If we have time, we'll discuss one question like multiple times. I'll be asking you, you can ask me, something like that. So until it gets into our head, and once we have kind of covered the entire question paper and the assignment, then if we have time left, we will study the rest of the stuff. So that way, on the day, just one day before examination, we don't have to worry about anything because we can just sleep peacefully. All be prepared. Yeah.
One day before the exam is not sleeping peacefully, but okay if you
No
say so.
chance of sleeping peacefully.
No, because if you're preparing in advance, then of course.
Yeah, I panic. I tend to panic a lot, especially
Hmm.
when I'm lonely, and which is why I don't like really love the system of IGNO, because like everybody is super lonely. But now
Yeah,
that
yeah, yeah.
you guys are there, like I feel, I was just telling my brother that you
Hmm.
guys like know much more than me, and he said that's
Hmm.
a good thing. So that it's good. It'll push you forward. And like, yes, yes, that's
Yeah.
true.
Cool. So yeah, go on. Read it.
Yes. Oh, and my internet like exactly at 7:22 it goes off every day. So like, just please add me back. I'll be there like within 2 minutes if that
That's
happens
fine.
again.
That's fine. No
Okay.
problem.
Database relation, example employee table. Each row of the table is called a record or tuple. Each column is called an attribute that represents values. Example employee ID, e-name, post, salary. A domain is a set of permissible values that can be accepted by a specific attribute. Example, the attribute salary can accept values from 5,000 to 100,000. The smallest unit of a data in the table is the individual data item or cells.
So
Example, Rahul.
yeah. So this is like the base, the strong the foundation of the relational database management system. You know, like you have table, then you have columns. So columns are also called fields or attributes. Then each of these are rows. They're also called records or tuples. Then you have primary key, which is a unique key to identify each row. You have domain, which is basically the range. Cardinality is the number of rows here, and degree is number of columns. And then each cell is called the data item or a cell. Okay,
Uh,
so the degree of the table, I'm going to move fast on this one because we don't really need to spend too much time here. So degree of table is basically the number of attributes or number of columns. The degree of table is 4, which already discussed. I always get confused between super key, candidate key, and all of that stuff. But super key is an attribute or set of attributes used to identify the records uniquely in a relation. Example, employee ID is a super key since employee ID is unique for each record or tuple. Similarly, employee ID and e-name together and employee and post ID together are also super keys for as long as their combination is unique for each tuple. Candidate key is a single key or a group of multiple keys that uniquely identifies rows in a table. For example, both employee ID and name can act as a candidate key for as long as they contain the unique and non-null values. So this is important, non-null. One of the key differences between a super key and a candidate key is that candidate key is non-reducible, which means, for example, in this case, employee ID and e-name cannot together form a candidate key because employee ID itself is unique, so it is reducible, which means I can just use employee ID. I don't have to combine it. But if this there was a repetition here, like E1 was repeating here on the third row, then probably we could have combined. But we can clearly see that there is no repetition; it's unique. So we can't combine these two to form a candidate key. Right, Samaya?
Yes.
Okay. Primary key is the candidate key selected by the administrator to uniquely identify tuples in a table. So, out of all the candidate key, you can only choose one as a primary key uh, that will uniquely identify the records. Okay, Kritika, go on.
yes, relation. A relation is defined using two basic aspects. A relational schema R specifies the relation's name, the list of attributes of the relation, and the domain of each attribute, which is denoted as R, A1, A2, AN.
Okay, so relational schema is nothing but the name of the relation. Let's say student. If this was student relation, then you'll put student here, and the list of attributes. So let's say if you had employee ID, you'll put employee ID here, comma, employee name, comma, subject, and all that. So that's kind of a representation of the schema.
The relation R has n attributes, which is also called the degree of a relation.
Again, attributes means columns. So if number of columns is 4 in a table, then that's 4 is the degree of relation.
For example, the relation schema of the relation person can be defined as person, person ID, integer, name, character, age, integer, address, character. Since the person relation contains four attributes, so this relation is of degree 4. A relation instance state R is a collection of tuples for a given relational schema at a specific point of time.
So difference between schema and instance is that schema specifies relation name and list of attributes. An instance is basically a collection of tuples.
A relation state R of the relation schema R A1, A2, An, also denoted by R brackets capital R, is a set of n tuples. R is equal to T1, T2 till Tm has m tuples, where each n tuple is an ordered list of n values.
I'll skip this one. Okay. Now let's move on to the DBMS, and we'll study till 8 and we'll call it a
Uh,
day.
just one. I have one question, and I thought
Yeah.
you could help me with that.
Yeah.
In the question papers, when we have something like you have a student name, student this, student ID, all of that.
Yeah.
Do you also write the SQL code for the schema, like in SQL fiddle on the left side, when we the code that we use to write the table, do we also write that, like a create table, include, uh,
Which question are you talking about?
let's say the first one.
Okay. So what is it asking you to do? Let's see.
So do
Uh,
we?
okay. So it's saying, hold on. So here it's saying university is planning with the following details. Okay, it's just giving you information.
uh, on the next page is the right side.
I think it starts from here, right? This is what you're talking about, or a different? What's the question number you're talking about?
Of Okay, let's do B, write SQL commands for queries. Yes.
Yeah, write
On
SQL
the
commands for queries on the following relation. So this is
mm-hmm.
your relation. It's giving you the
Yes.
name of the relation. It's giving you the attributes. This is another relation, and it's
Yes.
giving you the attributes. List
Yes.
all the account numbers in the order of the name. So yeah,
Yes.
you have to just write a command. You don't. I don't think you have to write a create table, because it's not asking you to create a table. All it's asking you to list it. So you do select what is asking you, account number,
Select account number where yes, okay.
account number from
Uh,
account where no, not where, but order by
order by
name.
name.
Yeah, so like
Okay.
that. If it's not asking you to create a table account,
We
sorry,
don't write.
command, then you don't have to write it.
Okay. All right. Okay.
Let's move
Thank
to a
you.
database. You're welcome. Let's move on to this one, assertion and exception handling. Assertion as per dictionary means declare positively. An assertion is a statement in Java which ensures correctness of any assumption which have been done in the program. An assertion is executed, it is assumed to be true. If an assertion is false, Java Virtual Machine will throw an exception error. It finds the application primarily for testing purposes. If conditional statement used to check the bug condition reaches the production even after the bug has been removed, they consume the CPU cycles and may be the cause of the bottleneck or resource crunch. This problem does not exist with assertions as they are disabled by default. So what they're saying is that assertion is basically used to ensure the correctness of the any assumption. Okay. um, Now in case if there is any error, uh, and if you keep the assertion on, then if you're running the production, it will take a long time because it has to do all the checks and everything, and it will consume a lot of time for processing. So that is why they always keep the assertion false by default, because that should only be used during development phase of your program, and then it should be turned off. So anyways, by default it's false, but if you are using it for development, keep it true and then turn it off for production. By default, assertions are disabled in Java. In order to enable them, you use the following command, which is Java hyphen enable assertions space example. Just 1 second. हेलो अम्मी क्लास चल रहा है, एक 20 मिनट में कॉल करता हूँ. 20 मिनट में कॉल करता हूँ, क्लास चल रहा है. Okay, let's move on. So writing an assertion. How do you write an assertion? Uh, Assertion in Java can be done with the help of assert keyword. The first way is assert and then your expression, and then second way is assert and then expression one or expression two. So this is an example. You create a main class. You do int age equals 14, assert age less than equals 18, or cannot vote. So in case if age is not less than equal to 18, then it is going to print cannot vote. And then if it's true, it'll say voters ages whatever that age is. So now you can see that this is printing that because age is less than 18 because age is 14. Writing an assertion, can you read this, Kritika?
Yes. When assertion fails, assert usually throws assertion error when the assumption made is wrong. Assertion error extends from error class that ultimately extends from throwable. Catching exception error, an assert statement declares a Boolean condition that is expected to occur in a program. If this Boolean condition evaluates to false, then an assertion error is given at runtime, provided the assertion is enabled. If the assumption is correct, then the Boolean condition will return true. The assertions are not required to declare them explicitly, and also there is no need to try or catch them. Asserting an exception. To assert an exception, we declare an object of expected exception as follows. Public expected exception is equal to expected exception dot none brackets. Then we use its expected and expect message methods in the test method to assert the exception and give the exception message.
So there's a space here, there shouldn't be any space. Confusing.
What does
I
it
don't think
mean the assertions are not required to declare them explicitly?
which one? Uh, where is that?
Under
This one.
catching exception error,
This
the
one.
last point. Yeah.
The assertions are not required to declare them explicitly, and also there's no need to try and catch them. Yeah. So remember, in exception, you have to try and catch them, right? But here you don't have to do that. You just have to use this condition. You just have to assert it whether it's true or not.
Okay.
You don't have to try and catch.
Oh, maybe it means you don't have to put something like throws exception or throws
Yeah.
assertion by
Yeah, and
declaring.
you don't even have to put it in try and catch block.
Mhm.
It's not required. You just use assert and you just put your condition there. That's it. I think with with exception, it's like if you don't handle them, the program is going to halt. It's not going to proceed further. But I guess it doesn't happen with assertion. That's why you're not catching them. Assertion, I think it's mostly used in testing purposes. Like when you're testing your program, you write a function, then you test whether it out gives the required output, the expected output or not. Okay, exception and its causes. Exception. Okay, go on, Kritika.
Exception is an unwanted or unexpected event which occurs during the execution of a program, that is at runtime, that disrupts the normal flow of a program's instructions. When an exception occurs within a method, it creates an object. This object is called the exception object. It contains information about the exception, such as the name and description of the exception and the state of the program when the exception occurred.
Okay.
Causes of exception: invalid user input, device failure, loss of network connection, physical limitations, out of disk memory, code errors, opening an unavailable file, the JVM has run out of memory.
Okay, so this is important. Exception. What is an exception? They might ask you in the exam. So it is an unwanted or unexpected event. When does it occur? It occurs during the execution of the program. Let's say your program is running and you're trying to, let's say, convert uh, a string into an integer. Okay. Now that string is like 1 2 in quotes. The string says 1 2 in quotes, 12 in quotes. That is okay, you can convert that. But if the string says hello world, you can't convert that into integer. So an exception will occur. If you handle it using like try and catch block, then the rest of the program, anything you write after that statement, is going to execute. But if you don't try to catch it, then the program will halt at that time. It will terminate, and that's not really good for your production environment. Like if one exception occurs, the whole site will be down. Another thing it talks about is that, so of course we spoke about disruption because it disrupts the normal flow of the program. It halts there, and it another thing it talks about is that when an exception occurs, it creates an object. That's called an exception object, and it contains a lot of information like what type of exception it is, what is the message. I think you have a get message function that you can use to find out what is the exception, what is the problem, name, description of the exception, state of the program, all of that. When does an exception occur? There could be multiple scenarios, like user entered invalid information. You were expecting him to enter a string, he entered integer, or your device fails, connection fails. Um, then physical limitations like out of disk memory. There were some code errors. The developer has written bad code, which kind of broke the program. Or opening an unavailable file. A file is not available. You're trying to open it. So you have functions that allows you to open a file. And if you put the incorrect path of the file, of course, the file doesn't exist. You're trying to open something, you're definitely going to get an exception. Java virtual machine has run out of memory. Maybe you have run an infinite loop which goes forever. You forgot to write the appropriate code to break that, and then it consumes all the memory of the Java virtual machine and it has run out of the memory. So these are some of the reasons why an exception could occur. Okay, go on.
Why proper exception handling is necessary. Separating error handling code from regular code. Exceptions provide the means to separate the details of what to do when something out of the ordinary happens from the main logic of a program. Propagating errors up the call stack. A second advantage of exceptions is the ability to propagate error reporting up the call stack of methods. Grouping and differentiating error types. Because all exceptions thrown within a program are objects, the grouping or categorization of exceptions is a natural outcome of the class hierarchy. An example of a group of related exception classes in the Java platform are those defined in java.io, IO exception, and its descendants.
I think Sumaya, you've written this, right?
Yes.
Good, thanks. Okay, let's do a recap on this one. So, uh, why exception handling is important? Separating error handling from regular code. Exception provides means to separate details of what to do when something goes wrong. Okay, propagating errors up the call stack. A second advantage extends the advantage is the ability to propagate error reporting. Grouping and differential error types, because all exceptions thrown within the program are objects. The grouping or categorizing of exception is a natural outcome of class hierarchy. An example of group-related exception class in Java platform, those defined java.io. Did we have any others, other like reasons why it's necessary besides these three? Sumaya?
No, I found just these three.
Okay, no problem. Okay, so just a recap. It provides means to separate the details of what to do when something goes wrong. Uh, the advantage is the advantage of handling exception is the ability to propagate error reporting up the call stack. And then all exceptions thrown within the program are objects. The grouping or categorizing of exception is a natural outcome of the class hierarchy. It's not very clear actually. I don't know of how it is helping here. Okay. Write a program demonstrate the use of catch clauses in exception handling. Multiple catch clauses, right? So we have a program with a function called main. We have a try method and we have multiple catch methods here. So here, what we're trying to do, we are trying to first declare an array which has 5 length, and I think this is static array. And then we are assigning the fifth element by dividing 30 by 0. Of course, 30 is not divisible. Okay, so we catch it, and then we know this error that's there is related to arithmetic operation. So there's a class called arithmetic exception. We use that. This is E is a object. You can write anything else over here also as the name of the variable. This will contain all the information about the exception. We just print it. This exception occurs. Then we catch another type of exception in case if array index out of bounds exception. I think it's gonna accept this value, whatever comes as an outcome. So that's when we will get this exception. So we'll catch that. So if this passes, it'll skip this. But if it reaches here and it kind of matches this type of exception, it'll print this. Then if it's not any of these two types of exception, it'll fall here. Exception is like generic. It's not specific whether it's arithmetic or bound. It could be any exception. So it's going to catch that, and then it's going to say parent exception occurs. And if it passes all of these threes, which means, if this code is fine, then it's just going to go to this line. Or even if it fails, it'll still go to this line because we are catching the exception. If we didn't catch this exception, if we just put these two lines and remove this try catch blocks, then if this fails, it's not going to go to the next line. It'll just fail there. So this line will not be printed. So that's why exception handling is important. Okay, this is another exception example. Here we're trying to uh, convert a string into an integer, which is not possible. This is an example of a single catch, and you also have finally method. A finally method will always execute irrespective of whether the exception fails or passes. So whatever you put here will always execute. So various methods of exception handlings are try, catch, finally, throw, and throws. We don't catch the exception using try and catch method, program will terminate. This is an exception hierarchy. You have an object of throwable class, and throwable is extended by exception class, extended by error class. Right now we're talking about exception. The different types of exception classes, runtime. So this is one we what we spoke about, arithmetic. We spoke about this one, array of bounds. So if you know what type of error you're going to get, you can use specify it. If you don't specify it, then you can directly just use this exception. So any type of these exception occurs, it can handle with this type of class. Okay. So Maya, do you want to read?
Okay. Types of exception. Built-in
I think your
exceptions.
cat heard it and she wants to read.
Built-in exceptions. These are available in Java libraries. Checked exception. Compile time exceptions, because these exceptions are checked at compile time by the compiler. Unchecked exception are runtime exceptions. The compiler will not check these exceptions at compile time. The program would not give a compilation error. For example, divide by zero, array out of bounds, null pointer exception, etc.
What is this array out of bounds?
If you are accessing an index of an array that's not there, like if the array is of size 5 and you're accessing index 6, I think that's what it
Mm-hmm.
is.
Okay, so in the previous example here, where is it? Uh, fifth element will not be there because it's 0 to 4, correct? You're trying to
Yeah.
assign you're trying to assign the fifth element, but this array has maximum size of 5. You can't increase its size because it's static array. So that's why it will not work, correct? So it'll go as array out of bounds.
Yes, but for this one, it will go in the first catch block, arithmetic exception,
Okay,
because of the divide by zero.
okay. But if we change the value for proper value, then it's going to go here. Let's try it quickly.
Yeah.
Uh, exception handling. Uh, so try int a bracket new int and it's bracket. They're going to be 5 elements, 0 to 4. Index will be 0 to 4. Am I supposed to import anything on top? A5 equals 30 divided by 0, and then catch arithmetic exception arithmetic, another catch block. Only finally here, forget about the finally. This time it's going to be array out of bounds. Array index out of bound exception. Okay, it's highlighted. Numeric overflow in exception. Okay, and then finally another catch block. This will be normal exception. Exception. E. So let's try it. Hmm. Cannot find class int. I have to import some. Which package is it in? Import java.util dot number. Sumaya, when you wrote this program, can you find out where you copied from? What's the thing I need to import here to get the int?
I think you don't have to import anything. Can you make
The
the int
spelling mistake?
lowercase? Yeah.
Yeah, I thought so. Okay. Uh, I think I'm doing the wrong one. Let's check with this one. Run. Okay, arithmetic. It's going to arithmetic. We went to the first one. Okay. Because 30 divided by 0 is the issue. Numeric overflow. Let's change it to a proper number now. 3. Now we should get array out of bounds because we're trying to assign 5. See, it's already giving me if you hover over it. Array index is out of bounds, which means I have 5 elements 0, 1, 2, 3, 4. So index 5 doesn't occur because index starts with 0. So let's run it. So now we got array index out of bounds. Awesome. Great. That makes sense. I think I should create another class here. Uh, exception handling multiple catch. Put that there. Okay, no errors. Excellent. Cool. Now we have both the examples. Move on. We'll finish this whole exception thing up until 99 and then we'll call it a day. So this is done. This is done. We did this. Yeah. So Maya, can you read this?
User-defined exception. In order to create a custom exception, we need to extend the exception class that belongs to java.lang package. For example, we pass the string to the constructor of the superclass exception, which is obtained using the getMessage function on the object created.
Okay, so this is the class, custom class myException extends exception. And then inside of this, we create a function called myException, and we call the constructor method of exception, which is super. Then inside of our own another class, we have a try and catch method. Here we throw the exception called geeks whatever, and then in the catch we print that is caught. And whatever we are getting in the exception object, whatever message we are getting, we can access that using .get message. That's what we're printing here. Go on.
The throw keyword is used to create a custom error, while throws keyword indicates what exception type may be thrown by a method. Throw is explicitly used to throw an exception, but throws is used to declare an exception. Throw is followed by an instance and throws is followed by a class. Throw is always used within a method and throws is used within the method's signature. Throw clause can throw only one exception and not multiple exceptions, and throws can declare multiple exceptions.
Okay, so here is an example. We have a main class. We have a static method called check age, and if age is less than 18, we'll throw an exception, access denied. Else, we'll just say access granted, and then we'll call the function inside of our main function. Notice we are not instantiating. No, actually, this is inside the same class. Okay, that's fine. Yeah, and then another example of throws. So when we want to use throws, we use throws after the name of the function, and we say arithmetic exception, whatever that exception class we want to use, and we do the same thing here, which is throw a new exception, and then over here we just call that function. Okay, so we'll pause over here, and then we'll continue tomorrow with the DBMS, and I think we're done with 100, uh, and then we have another 107 left to revise. Cool. Thanks, guys. I'll see you tomorrow.
Thank you.
Welcome. Bye bye.
Bye. Good
Bye.
night.
Bye. Good night.